I'm going to talk about the flowcharts that I created. Then I'm gonna go over the code. I think I'm gonna step over to show the functions there. And after that, I'm going to continue to follow the steps that I have there. And I'm going to create a module on Godot. Things are starting to become more clear, but I'm still confused about because I have to change the mentality that I have from the other project that I was doing to the way that Godot works. And it's kind of confusing to think about how, at what point each thing is gonna go. But I think things are starting to get more clear on my mind. So I'm gonna put 1 hour and a half. Hey, what's up? And then after 1 hour and a half, I'm gonna take a break. I'm probably gonna do some tea. So I think I'm not gonna spend too much time on this because it's better to see it from the debugger, I think. But basically, what happens after you so this flowchart is from when you click the right button on the mouse, and then you select add child node. Then, if I remember correctly, it's gonna open a pop-up, and it's gonna display all the nodes that are currently available. And then after you select one and you click on create, it's just gonna load the node, let's say, on the viewport. And all that is happening on that phase is that Godot is creating a temporary file and then writing information to that temporary file. And I assume, I haven't studied yet, this is part of the things that after I create the module, I think I'm probably gonna do this, which is study the save scene functionality, because I think it's on the save scene that it actually translates the information from the temporary file into the final file, which is the sync file that it is saved on the project directory. And the reason why I think it is like this is because the export template functionality works pretty much in the same kind of logic. They create a temporary file, then they write information to that file, and then only at the end they update the original file with the temporary file. And then they delete the temporary file. And basically, I'm still struggling a little bit to understand how exactly it works, but pretty much all the GUI elements are going to have the same classes, and the only thing that changes between them is the data at the moment you interact with Godot. So they all use the same classes, the same nodes, which are control nodes, I think, in the base. So like the way that Godot creates the GUI is the same way that they allow you to create your GUI for your application. They use the same nodes. So when you create, usually when there is a pop-up, eventually they're gonna call the window node, which is the base class for the control node, if I remember correctly. So I think that at the base, I don't remember which one comes first, but there is both the viewport and the window. And the window class is the one that is gonna call the display server, which is the class that they use to manage the actual window that shows up, and to also does the drawing, or is connected with the stuff that does the drawing. So basically, the way that it works on all the main components, let's say, is that each one is going to be one class, and then inside of the class, you're going to have other classes that are these ones that are reused all the time, which is the button and other stuff like that. And so the confusing part is after you click a button, it's kind of hard to know at what moment that function was called, because the name of the button changes depending on what kind of event was set before. But it's basically after the event, and I think I explained this on the last stream, is basically because Godot's going to process the events each time on the main loop. So it's basically after After the event is put on the queue from the window that is created on the display server, because Godot processes these inputs. So when you interact with the window, it's going to send to the Windows API, which is going to send to Godot to the input class, which is going to update the viewport class, I think. And the viewport is the one that is going to call the GUI input function, I think, for the elements that was interacted with, which in this case was a button, I think. Either a button or some other stuff like there. Create dialog, I think. So yeah, so that's basically what is going on. So in this mesh, I think that there isn't anything directly correlated with the classes or with the scene file. So yeah, I'm gonna explain the attached script, then I'm gonna talk about what I clarified recently. That is becoming more clear. I'm still not 100% sure that's how it works. I'm just gonna follow here. So the sync tree doc is the thing that shows up on the node selection on the left. This class here is responsible for everything that happens, and then it has only one function, I think, that has a switch statement that is gonna determine what's gonna happen depending on what kind of node you interact with. And I think that this sync tree doc class keeps track of all the nodes on its tree data structure. So it's inside of this thing, which is not the same one that Godot uses to render everything. It's just another struct that they use to keep track of the information so that they can display what is going on. So up until here, I think that this is the first. So after you click attach nodes, is the first thing that shows up there. Probably gonna. I'm not gonna open the one that I have on the debugger because there's a bunch of breakpoints, so it's kind of annoying. But after, I'm gonna go over probably with the debugger. So these functions are separate flows. The pop-up grids opens the selection gear to select the nodes elements to be created. The rest of the flow is after selecting on one and clicking the create button. Yeah. So this part's very simple. It just opens. It calls the window node to, and this is a function that is reused all the time as well. I think all the pop-ups work like this. That they have an event, then like the thing that is interacted with has an event. Then after that event, that function is gonna emit a signal, and then that signal is gonna call the window function eventually to call this pop-up function, and then that function opens the pop-up and sends another event. That's pretty much all the pop-ups work like this, I think. The functions that runs after clicking the create button emits signal that calls this function. And so like I said, so this flow here is after you click on the create. You selected the mesh and you click the create button. And this is the main thing that I found interesting there. But this app here, so this function is opening a file and is getting based on the project settings there, and is joining with create recent. And the project settings is on the. So the root of your project is going to be ras, and then two dots, and then slash slash. So it's going to be ras, and then if I remember correctly, it's going to be editor or Godot editor, and I think that's the project settings. And then it saves the temporary file there. But this app here is going to use this app to store the information of what you selected. And I think it's going to use this temporary file to create whatever shows up on the viewport. But that's not the same file from the final scene file. Because then when you click on Ctrl S, that's when it's going to, I believe, change the information from the temporary to the final scene. But I'm going to put breakpoints. I already put breakpoints there actually. So I'm probably going to study that after I do, I create the module. I'm going to open the, so it's basically this folder, and I think it's on the editor. I don't remember really well. But they probably delete the file, so it only exists. Oh no, so it's still here. So this is the file there that it creates on the thing. But there are more, no, maybe they don't delete then. So this is the other file, the temporary file. So on the exports templates thing, they delete the file after. But here apparently they don't. Hey, what's up? So basically what I'm talking about is this scene tree doc is this stuff here. Only the scene, not the file system. I think each one of them is a class, like I said. And then after, there's gonna be inside of the class there is other classes that handle other stuff. So that flow is related to this agile node here. So it opens the GUI first, and then there's another function there that is a select function. So the select runs each time that you click on one node, because I think that it changes some state of the select of the sync tree doc, and after you create, it uses the select member variable, I think, to determine what is going to write on the temporary file. So I think that's pretty much it from that thing. And then now the attach script. So I'm just gonna glance over this, and then I'm gonna show the debugger. But it's basically the flow after you click here. So it just opens a GUI, and then after you click on load, then you select, you can change the name here, and then when you click on load, there's gonna be another function. So the first functionality is similar to the previous one, where he opens a GUI pop-up, and then after you click on the load, there's other stuff that happens. So basically, these are the functions that happen there. So this is the first part before this thing here. It just calls, it's from the sync tree doc as well. So this get selected here is the sync tree doc keeps track of all the information that's going to display there. And the way that it does that is by searching the class DB for all the classes that are subscribed on the project, which is basically how it works. And this is the part that I was confused about, and I'm still kind of confused because I have to clarify more how this works. But basically, all these functions here are called before. And also the interesting thing is that on here they update the set project metadata. And I think the reason why they do this is because the GD script file is different from the mesh, because the GD script, when you attach, is going to create actually the final file, which is the one that shows up in the bottom here. So that's different from the mesh, because the mesh creates the temporary file, and the GD script creates the final file here. And I think that's the reason why it changes the project settings or the project metadata to keep track of whatever scripts the project has. So, but the part that I'm trying to clarify, and the part that's kind of confusing, is what is the relationship between the script and the node, and at what moment does Godot going to run the script? So that's the difficult part, because when you attach the script, you are attaching to a node. So if you don't have any node selected, it doesn't show anything when you when you use the right click on the mouse. But when you select, then it displays the option. So the attached script is going to be from, you can only do it on a node. And I think that based on the stuff that I've seen from the source code, I think that what it makes sense is that the script is a member variable on the node class. So when you click attach script on the node, it's going to update that variable to have information of the path of the file that is related to that script. And then what Godot is going to do is going to use the script server, which there's some functionality there that is related to this. It's going to use the script server to get the language that the script was created with, and then it's going to parse the script and it's going to add that logic in whatever events the node has. So the way that it works is that during the rendering cycle, at certain points, Godot is going to emit events to nodes. And this is another thing here that I realized that they display here. So you can look at the points, and they have the explanation there, at what phase of the rendering cycle the event's going to be emitted. So I think what GDScript is doing is they're just parsing the whatever code you put here, and it's like putting this code together with the codes from the node of whatever is going to happen during that time on the rendering cycle. So this is the thing that is kind of confusing, because I'm not 100% sure if that's the relationship between the script and the node. But then the way that I think it works now is that, because the thing that I'm trying to do is one of the things that I'm trying to do is to be able to write the scripts with C++, so that I can keep everything on only one language. But yeah, obviously to understand that, to do that, I have to understand how the connection of the script with the node works. And then I remember that there is the GD extension and the modules that they allow you to do. And there is a documentation here. And the difference between the two is that GD extensions, you basically create a separate library from the engine. So you can compile the library on its own. And then kind of like couple the library with the engine. And modules, you have to compile everything as part of the engine. But they're pretty much the same way that it works. So basically, as far as I understand now, the part that is confusing and I'm trying to clarify, so that's why I'm going to build a module for other reasons as well. But the way that I think it works is that once you build the module, all that they're telling you to do here pretty much is the same way that you subscribe any class on Godot. Use this macro here, and now it's becoming more clear as well because GD is not related to the GD script. It's just a shorter way to say Godot. So whenever you see GD, it doesn't mean that it is from GD script. It's just abbreviating Godot. So GD class and GD virtual is not necessarily related to Godot. The class that is related to the GD script is a GD script. Yeah, I think it's GD script class, which also shows there at some points when you attach the script. But basically, this macro here is used to, it works as part of the object class. It's like an extension of the functionality of the object class. And what this allows you to do is that you can subscribe the class to the GD class or to the class DB. That is the class that Godot uses to keep track of all the classes that the project uses. So that's pretty much all that is happening here. You're just subscribing the class that you created using this bind method here and the register class function to the class DB. And then Godot's going to know that the class exists. And then after you do that, what it can do is just search for the node here. So it's as if you're creating a new node. So, and this is related to GDScript functionality because one thing that you can do is, the reason why you can write scripts like this is because this node here that you create from the modules can be an extension, or you can inherit from any node you want, obviously. So it's kind of like you're creating a child of a node. So you can select, for example, Object 3D or Mesh Instance 3D or anything like that. And then I can put extra functionality here. And then what is going to happen, and this is the part that I'm not 100% sure, but I think what's going to happen is that either you can create new functionality that is going to happen whenever the node enters the scene or whatever the steps are there that it shows here, or it's going to override the custom node functionality because it's going to call, when it meets the signal for the node, it's going to call the function that you created on the custom class. But this brings me to the main problem that I have, and I'm trying to clarify, which is kind of difficult because, so it comes down to whether or not when you emit the signal on this parts here of the process, if it's going to call the function from the lowest class, from the derived class of all the other classes, or if it's going to call the function from the parent classes. And I think it makes more sense that it calls from the derived class. But then the problem is that it becomes kind of confusing to think about how we're gonna, because the thing that I'm trying to do is the first thing I'm gonna do is create a graph class. And I'm trying to translate the mental model that I had before, which is I was creating the graph outside of everything. Then I was creating the meshes separately and the nodes separately. And I was adding to this graph data structure. And then on the middle of the physics cycle, of the rendering cycle, I put the physics equation for inside of the graph, which is the Barnes-Sutz equation, to solve for that. And yeah, so basically those things are decoupled. So the graph was separate from everything, and the meshes, the sphere meshes and the edge meshes and the arrow meshes were part of the rendering thing. But here it changes everything, and that's kind of the problem, because if I am going to create this graph class, then I have one way, and it is the way that I'm thinking about doing now, is, so the previous way actually I was thinking about is creating another node using modules and then inheriting from the Mesh Instance 3D, for example. and then putting the functionality there. But I don't think that makes a lot of sense because it's kind of weird. I don't know, it just doesn't feel that is the right way to go about it. And the other way is to also create the module. There's actually a bunch of different ways, but the main one that I'm thinking about now is create a graph node and then make that node the parent of everything. And then on that node, I can put the physics functionality and just make it based on whatever children the node has. So basically, to clarify these things is going to come down to understanding exactly what are all the functions that the node class has available to it on the rendering cycle and what kind of stuff you can put there. So I'm gonna just build things and then see what happens. But that's the idea that I have now. So create a module that is gonna be. I'm gonna follow the documentation here, and then later I'm gonna change to be the graph. Then I'm gonna figure out I'm gonna look for the source code to see if I can get information from the children of that node, so that if I can, then I make the functionality of the graph based on the children of the node. So just append all the spheres and edges, and this part I'm not 100% sure, but I think that makes sense if I append all of them. So the graph itself is going to be one node of the visualization, which was different from the thing that I had before, because before it was separate from the whole thing. So I have a bunch of questions basically related to this. But basically all this stuff here comes when you click here, and then it opens up this stuff here. And then the rest of the functionality comes later. So it's similar to the other one. This accept dialog, which is a part of the scene tree doc, calls this okpress function, and then this is slightly different from other situations, but this function calls this other okpress, and this other okpress calls this create new, and this create new is the main function that is going to be related to actually creating the script, but that I'm not 100% clear. But the part that is interesting is this GD script here. So this is called after it calls another function from the script server, I think. So the script server calls the get language, and then from that point it calls this make template, and then it passes as an argument, I think, this L path here. I don't remember really well. But the path here is the path to the GD script file that you put here. And then from that path, it initializes the GDScript. This GDScript class is the class that handles the GDScript functionality. So yeah, it basically saves this path here in some class that is a part of the Synctree doc. And that's all that I figure out so far. And the other main thing is uses this resource saver here, which I think it saves the GDScript as a resource. So the difference between GDScript and the meshes is that the base class of the meshes is the node, and it is the stuff that is the nodes are the stuff that are gonna be appended to the sync tree, which is gonna be the stuff that is gonna be shown on the visualization. But then you have other things like, I think these things can overlap on the sprite, for example. But the resources is the stuff that the engine is gonna need. So like images and stuff like that. So GDScript is from resources, inherits from resource class, I think. But basically saves on the resources. So it's slightly different than the meshes. But I think they overlap when it comes down to sprites, because I remember that there is a sprite to the node as well. I was gonna say something else there. I forgot. There's so much stuff. Another thing that I was trying to do is to debug the game, but I couldn't do it because it doesn't have symbols, which makes sense, but there is a way to export for the debug version. But I tried that as well, and also it didn't work. So I'm not really sure if they did it like this on purpose, because it would make sense that they do it like this on purpose, because if they didn't do it like this, then you could just download a Godot game and then use the source code from the engine to debug the game and try to figure out how they created. So maybe they did this on purpose. But the idea I had was to step over an actual game. I downloaded an example of a game to see at what point exactly does Godot triggers each signal and how they're gonna impact how they're gonna use the GD script each node. This other thing here, as far as I understand, I could be wrong, but I think that the stuff that shows up here on the Spectre is basically this class here, Spectre doc. So everything works like this. There's a main class that is going to show up everything, and then inside of this main class you have these other classes that are reused all the time, which are control nodes. Those control nodes are going to override the GUI input function, which I think is a function for a control node, and then on the GUI input there's going to be the functionality of what happens when you interact with that thing, because it's going to use the viewport in the window when it's processing the events there in the beginning. I'm going to close this one. There was another thing that I wanted to talk about. I put this one, I'm going to try to leave it here if it doesn't bother that much, but this happens at some point there inside the control flow here. I don't remember exactly where, but I think it's at the end here. It's after the script created. And this function I found that interesting because this one is going to be related to the tree. So I think after it adds the GD script, there's something related to updating the nodes on the tree. And I think it's just because when you update the state of one node, you have to call this function, but I'm not 100% sure. This kind of stuff I'm still trying to clarify. So let me see if I can show maybe the header is better. So the sync tree is the main thing, the main class that is the host sync, and then everything's going to be appended to this. So to show what's going to happen there in the beginning, I have to put the other breakpoints again. But I don't remember which order it is, but I think that maybe I can just go from the inheritance of one of the nodes, I think. Yeah, this thing here probably. But I don't remember which one is the parent of which. I think that the window is the parent of the viewport. So the window is the base one. And the way that they create the window is by using, if I remember correctly, is like a global class. So even though they create the window on the display server class, the other classes can call functionality from that because they use the namespace to call the function. So it's kind of like calling static methods. Could be wrong, obviously, but as far as I understand, that's how it's working. And the problem to understand is I have to go back to the window creation thing. It's gonna be annoying. I think this is gonna inherit from resource. I don't remember below. No, this is inherits from node actually. Yeah, nodes. So it's the node that inherits. Maybe it's somewhere else. I have to see if I can, because I don't want to spend a bunch of time stepping over again. I have to see if I can cache I mean, maybe on the first pop-up there, I can see. Because I'm pretty sure it's going to be on the pop-up function, so I can just go from there to show the relationship between the window class and the other stuff. This is another call there that happens on, I think, is on the attached to the script, which is resource save. This resource save calls this other function here. It's kind of the annoying thing about pointing these breakpoints here. But I think all of these, they allow you to see what's going on, to interact with the editor. Some of them is only if you put conditional breakpoints, otherwise it doesn't work. Where did I put the timer? Oh, so it works. So when you click select there, there's another thing that is gonna happen before. Each time that you change the item selected, it changes the state of the scene3 dock, I think. This is one of the, I think this function is called also after an event submitted, but I don't remember really well. I'm just gonna press F5 because I have to put the breakpoint there again. I have to figure out. There's before this all this stuff runs. There is a function that calls a select function or something like that. And on the scene3 doc, there is a member variable called selected, which represents the node that is currently selected. So let me show this one first. Basically, this is the main function. So as far as I understand, this function is always called when you interact there with the scene3 doc. So this function also has the attached script functionality. So depending on what kind of, I think this switch statements here represent whatever options you have there when you click on, when you use the right mouse click thing. Yeah, so the attached script is this one, and the mesh thing is the default, I think, or no, create or to new. There was one that I was seeing that is the default, but maybe it was another thing. I'm just gonna go over. So this is before it's gonna create the actual mesh. This functionality just to open the pop-up there. So it gets the current edit sync from the editor nodes. This is the other stuff that I'm trying to figure out. But I think for what I'm trying to do is not necessary to know that much about these other things, because the main thing that is important is, so there's two parts. One is to be able to write information to the write and read information from the sync file, which is the main file that is used. And the other one is to extend the functionality of nodes, so you can put your own code of to determine the behavior of the things that are interacting with the visualization, so the nodes. So those are the two things. And yeah. So to use everything on C++ comes down to understand the modules, I think, more. And then the rest is figuring out how to write and read the files. And then after you do that, and this is the thing that's the part that I was struggling to understand, because I was thinking about, like, the GD script creates a new file, so that's the main difference. But it ends up being pretty much the same thing. And I think the reason I was confused is because I was thinking about the other project, the way that I did the other project. Because on the other project, as far as I remember, I didn't add functionality to the nodes themselves. And I didn't view the graph as a node. So this is the thing. But here, since so like every time, and this is kind of the problem, and I think that the reason why it is like this, the reason why I'm kind of struggling to think about it is because the way that they decided to create the design is from object-oriented paradigm, and I think the way that I was doing before is more merging the two, where the graph, like I have a bunch of classes, but they are connected through functions. And here, it kind of forces you to create a new class if you want to implement functionality. And I know there is another version of Godot called Godot that uses the entity component system design. And the entity component system favors more composition. And composition is creating separate classes and using them on each other. And I think that's more of the approach that I was going with on the other project. So I think that's the reason why I'm struggling a little bit and finding a little bit weird, because it kind of forces you to. And if you think about it, like how can I do it if I don't? How can I implement the graph functionality without creating a new node to change the behaviors? It's kind of hard to think about how to do that, because then it might require you to change a bunch of things. But I think that's how they force you to do the way that it is right now. So you can view the scripting functionality as the adding the GDScript file, which is going to be a resource, which is going to be a member variable of the node class probably. Or you can view it as creating new classes and then just either extending the functionality of a class so you basically inherit from the class and then extend the functionality to change its behavior. So that would be like kind of creating an animation for sprite or creating an animation for a mesh. You would create a new class, inherit from the whatever thing you want to animate, and then on the derived class you put the new functionality that you want. Or you can go the other way, that is the way that I'm thinking about, but it's basically the same thing where you create it basically is going to come down on where the class is on the hierarchy of the inheritance, I think. So you can add the functionality of the class based on whatever, if you can do that. I'm not really sure, but probably you can. So just create the class as a parent, and then you add functionality to the children by getting the child nodes or the children from that node that you created, and then doing stuff with that logic. So I think that's basically the main ways. So when it comes to the final scene file, is not that relevant, because all you have to do when it comes down to the scene is to add the new node you created, and the functionality is not related to the, which was the confusing part, because GDScript is related to the files, but it's not necessarily the case that if you want to extend functionality you have to create new files or deal with the file system, I think. Basically here is gonna, I think it sorts the search options that it shows there based on these base types, and I think these base types are the ones that are like the base types of everything. So either you have a 2D scene and you're gonna use the node 2D, or a 3D scene, node 3D, or you use the control node, which is for GUI elements, I think. So I'm gonna try to see if I can show where the windows called are. And basically, I think all of the pop-up elements work like this. So there's a function from the elements. So this create dialog is probably really used on all the pop-ups, but the only difference is the place where the create dialog was created. So because that's going to change the data, I think. But I'm not really sure. Yeah, but I think that's how it works. So the search box is the search that shows up there. Then it calls this update search to. I think this is the function that checks to see if it checks to see the options, and the way it does that is by using class DB. So class DB is the main class that is going to keep track of all the available classes on the engine. So when you create the module, you're just updating the class DB, so that way the editor has access to those classes. And this is the thing that I was talking about that is gonna I think that it also has a member variable, but I don't remember it really well. But it basically creates another class or struct to keep track of the states of the stuff that shows up there, which is different than the nodes themselves that are used on the visualization. There's already, so someone is asking if ECS will be part of the Godot in the future. I don't think so. I remember there's reading some stuff that they were, I'm not really sure if they were interested in implementing or not, but there's somewhere that I forgot where I found that. I think it's one of the creators talking about this, but on that article, I think they talk about this other project here, which is the Godax. And Godax apparently is Godot using ECS. So they basically changed to Godot to use ECS. I'm not gonna do this now because I think it's gonna be too much work now that I already know, but maybe at some point in the future I'll study this as well. And the main thing here, I'm not really sure if it works for all platforms. Yeah, but I think to change the way that Godot is now to use ECS, you probably have to change a lot of things. So, because it would change everything, I think, fundamentally, of how all the meshes work. And this thing, I'm not really sure if it has the editor as well, or if it's just the engine. Yeah, the test Godot versions master. So I think there are some problems with some platforms. I never used Unity. I don't like the. So basically, I'm not really sure if I have access to Unity's source code, but I do remember, I think it is from one, like they create the engine from using another language than C++. And like one of the main things that I don't like is, like, obviously I like Godot more because it's just open source. That's one of the main advantages. And the other thing, I'm not really sure if Unity allows you to look into the source codes, their source codes. I know that Unreal Engine you have to subscribe to something on the GitHub there. It's free, but you have to subscribe to see the source, and then you have to change the source if you wanna use it. And I don't like the idea of, so it's like if you only use Godot using the GUI, I think that's very bad, and I think that's all. The same thing with Unreal and Unity that probably most people do. Because the issue is that, like, I think it doesn't matter. It's not a very big problem if you use the GUI, if you understand everything that is going on. But I think it's a problem because people, they only use the GUI, and then you become better at using the GUI, and so you become better at Unity or Unreal, but you're not becoming better at game programming or programming in general. So I really don't like that. It's like a different thing. So this is not still related. So there is some stuff here that is interesting, which is pretty much the stuff that I showed there. So I think it's gonna call this probably again when you click on the create button, or because this is the mesh, not the thing. But it's probably gonna call this function with other parameters when you're creating the script. So on the attached script, it calls this function again, but then it calls another one of these options here. Because I do remember Like this is basically the stuff that I was showing there on the flowchart. The script server is the main class that they use. I think it's a global class that keeps track of all the languages, which are the scripts. And then the here is script, but pretty sure that there is a GD script class that is the class from GD script that manages GD script. Yes, I'm trying to use C++ as a script. I want to do everything on the same language basically because I think it makes it a lot easier and C++ is faster. So I don't like this idea. I understand why they did this way because they talk about it in the documentation as well, on the fact that they have on the documentation, frequently asked questions. They say that the reason why they created GD script is because it was very hard to integrate Python or JavaScript or some other language on the thing, which makes a lot of sense because I imagine it's already extremely difficult to create all this stuff here. Like it's very impressive that they were able to do all of this. So I understand why just create a new language because it's easier to integrate. But then the problem is that like you have to learn another language and it becomes like a separate thing. Is a lot. So I don't know. I prefer to try to keep everything on the same language. I think it's easier to think about it. But if I remember from some videos I saw, you can use other languages if you do the GD extension or the modules. It allows you to. I remember seeing a video on Rust, people doing stuff on Rust. So this is the one of the functions related to the selectioner. I think it's not this one, maybe. No, I remember seeing this one a lot, so it's probably this one. It's related to showing what thing is selected. But I'm gonna skip all this stuff. So this is the function that shows up every time there. So this function changes the. It's called based on which item you selected, I think. Because the scene3 doc keeps track of the information on the class. So it's not gonna show. Maybe I skipped the function that shows the pop-up there. Or maybe this is another thing. Oh, I think I didn't skip. It's probably because I put the breakpoint on the update tree there, maybe. I had to remove, I think, that update tree breakpoint because of some like this, where it just starts going through to tree related stuff and then deviates from what I was trying to understand. So basically, this is still the pop-up function there. So here is a place where I think it changes the button there that is going to display on the pop-up that opens. So the button is always the same that all the pop-ups use. So it's the same class. But then on this function here that is called directly after the thing is interacted with, like first it's going to call these functions that are related to creating the pop-up. Then on these functions is going to set the name of the button that shows there. And I think the name changes depending on what kind of thing you selected first. So I think on the attached script it's going to be a similar thing. But then when it comes down to this point, it might create a new name on the label to display a new name, but it's the same button that is being used. And that button is going to emit, I think, a OK pressed event. And then that event's going to have the functionality of whatever happens after you click the button. So this is another it's interesting, but it's very complicated, which is basically they have, as far as I understand now, they have a undo and redo history. So basically is whenever you press Ctrl Z, usually on applications, or when you press Ctrl Shift Z, you can go back and forth between things you did. And in order to be able to implement this, they have to keep a history of everything that was done, I think. I'm not 100% sure because I didn't dive too deep into this, but I think that's the reason why they have this function here. So it just keeps track of a bunch of things, and it's probably on a temporary file as well. It's on this great recent file. So maybe the temporary file is not related to the mesh, what's going to be displayed. Maybe just tracking the history. And this is going to save the resource. So maybe yeah, now that I think about it, maybe the temporary file is just to keep track of the do and redo history, and this is the main function that is going to be used to. Yeah, but I'm not really sure that makes sense. Like, it doesn't make a lot of sense because I don't think that's the main function. I think it's just related to the history. Because the main thing that is going to be used by the engine is the final scene file, I think. But it might be. I'm not really sure. I think it's more likely that it's related to the temporary file and not the scene. It's temporary. But I still don't understand very well how they use the after you click the create, because this functionality that I'm showing now is just before it opens the pop-up. But then after you click on the create, I still don't understand very well how they create the nodes to display on the viewport there that they have on the editor, based on, I think it's based on the temporary file, but I'm not pretty sure. But it doesn't matter that much to me as well, because if I can figure out how they update the scene file, then I can create the nodes programmatically. Also, this is on the editor settings. So this is the main one, I think. It has to be this one. So this one calls the window class. So it calls from there. So it means that the whatever class called this has to have it has to inherit from the window, I think. So it's probably this one. Yeah, otherwise, how we would be calling this. But I don't remember if it was this one. So, yeah, so this inherits from the window. So it's window first and then viewport. So I think all these classes that, maybe not all of them, but the main classes that create the functionality to display things, they inherit from window. Yeah, the classes that are actually going to draw stuff to the screen, they have to inherit from the window, because the window is the one that has stuff related to the display server. And the display server is the class that is used to create the actual window using Windows API. So that function, though, from the window pop-up is going to be the one that calls display server to create the stuff. And that's the one that actually draws things to the screen. It uses canvas item to draw stuff. So this, I'm not gonna show this stuff, I just wanted to show this. So these functions here are the ones that are gonna be used to draw stuff. So it sets the position first, I'm gonna spend a bunch more time trying to understand. But like I'm gonna choose spend time studying this stuff when it gets to the point where I have makes a lot more sense to create a module first and then try to create some simple stuff first, and then once it gets time to actually develop this stuff that I'm trying to do, then I think it makes more sense to think about this stuff. But I'm not really sure if it's gonna be necessary because the functionality comes from these other classes. So what I can do is just use the same classes as well to create the GUI elements. So just copy everything that they do on the editor and just use on my application. So that's another thing. But obviously, eventually, I want to understand more how it works as well. Hey, what's up? I think that the reason why they can do it when they call in the way that they call there is just gonna call the function from the global class. Because if I remember correctly, the display server is initialized, yeah, is initialized as a global class. So they use this single pattern. So yeah, that's basically. So when you call from this, it's calling the same display server that was initialized in the beginning when you calls main setup function. Yeah, so it initializes like this, and then instead of the main setup function, I think it's main setup true, it's gonna call a function that allocates memory to this thing here. I'm not really sure what you mean. Someone's asking hi, last time I watched you once, like 18 months ago. Really wanna know where you did you get? No, I don't know what you mean by that, man, or woman, or whatever you are. So you can see there that after he calls this things here, this is the stuff that actually draws the GUI, and then this is the stuff that sets it visible. So I'm just gonna skip all this stuff. So now that's the main thing that I want to show there. And I think that this is not that relevant. So after this, it's just gonna call this. That this flow here is what happens after you emit a signal. It's just gonna destroy the callable, and then it's gonna go to the loop that I showed on some streams ago, that displays the whole process of the functions that are called after an event was triggered. But this is obviously the opposite thing because it's going back the stack. But those are the functions that are called after the event was triggered are. So it runs all the functionality for whatever the button function had, and then after this goes back the stack. I'm gonna press F5 here. I'm not gonna show everything. Then I'll be right back, and I'm gonna select one here and then click create and show the rest. But I think I'm gonna go faster to this stuff. Yeah, I'm probably gonna. So I'm just gonna stop this one. I'm gonna show the attached script faster, so I can start creating the actual or reading the documentation and trying to create the module. So I can create the new node, and then I'm gonna see if the new node shows up on the thing here. That's the main thing that I'm interested in on now. So I'll be right back. Oh fuck! I was talking about a bunch of things, but the microphone was muted the whole time. Yeah, but whatever. I'm not gonna spend more time on those things because it matters more now to focus on this other stuff, and I'm probably gonna spend more time trying to figure out how to deal with the other stuff. So I have to think about a name to put here. Maybe I'll call Brahma again. I'm not really sure because I don't wanna I, I don't have to create a new folder every time that I want to create a class. So the idea that I have is just create a folder and then inside of the folder just change the files there to add how many classes I want, whatever classes I want. So I wonder why they create the memory for this class but register this one. I'm trying to understand here is that there's a bunch of different files, but there's only one class that is registered here. So I don't understand how this works. And let me think about a name. Be a good name. I think I'm just gonna put Brahma first, then I'll think about it. But I don't like Brahma that much. But maybe it doesn't matter that much. I'm just gonna copy the documentation. I'm gonna copy the names and everything. I don't know which one of these has higher. So as far as I understand, like just based on what is here, I think that each module, they talk about this, I think on the documentation there. Yeah, each module is going to depend on what kind of things you need from the engine and other things. So if you want to build different modules that require different things, it's going to change what kind of level of access you need. Because I think you can change how much of the engine you want to compile, what kinds of parts you want to compile, and what kind of parts you don't. So basically, this level here indicates which one you need. But I don't think that's, I don't know like what is the, if there are levels, like the server is gonna have all the other stuff embedded into it, or it's just separate things. I'm just gonna follow the documentation first and see. The main thing that I wanna see clarify is whether or not it works in the way that I think it's gonna work, which is just gonna display the class there as a different node. That's the main thing that I wanna figure out. And after I figure this out, then I'm going to spend more time thinking about it. Yeah, I think that the next thing that I have to do, so I'm gonna write here. So this is what I was gonna see, is if there's a difference between the custom node in the way that it's gonna display on the final scene file or not. And then scene functionality. Oh yeah, so study node class. Should see. I'm not really sure if I'm gonna be able. So I can search for the functions as well. So study node class to see if it's possible. I think I'm pretty sure that it is because I remember, like on GDescriptor, I remember seeing people call the get node function. But I guess the get node is the current node, not the. But yeah, there's probably functions for this. So the other thing, search for the names for functions that show on the signals are. I forgot the name of the thing. So I'm gonna open the editor and I'm gonna search for the functions. If I remember correctly, each node that you select is gonna show different events you can access by through the node on the right there. And I think that those are just functions from the node. But I wanna see at what level those functions are at. So I think I have to. I just follow the documentation here. I'm probably gonna change the way that I'm gonna use the macro that GDScript uses. Yeah, so let me test now, just see if this works. It might take a long time if you have to compile everything again. Also, it's kind of fast. I think it's fast because it just recompiles whatever it needs, and the rest is cached. If it works, then the first thing that I'm going to do is change the name of the class. Hmm. It was probably because I put Sumator. Yeah. So it has to be the same name. Bro. So the folder name has to be the same name of the thing. But I guess it doesn't matter for our functions. Or for the classes, I mean. So I think the module name has to be the same, but then you can create as many classes you want inside of this function. Yeah, I'm not really sure. I'm gonna take a break, then I'm gonna make some tea. I'm gonna come back and try to figure out. I'm gonna try first to see what happens. Then I can think about it as I make some tea. Maybe not. It might take a long time, so I'm gonna go make some tea, and when I come back, I'm gonna continue to do this stuff. So it might take longer than half an hour, but I'm gonna put the thing here. So see you soon. Yeah, I'm back right on time. It looks like you worked here. So let's see. I might have to remove this so it's not annoying there. It doesn't look like it has anything. It should be this name here, I think. I'm pretty sure that it isn't that node because it should have the same name, I think. A base class for all scene objects. Hmm. That is the same thing. So on the documentation they talk about calling the node from the GD script. That doesn't make any sense to me. It's still a problem if I can use the class by and put it on the scene. Let me think about this. If I can use it and put it on the scene, it doesn't matter because it has to be displayed on the editor as well. So I'm guess I'm gonna have to spend a bunch of time looking more in depth into the create node thing there to understand how the scene3 doc is gonna get the classes. Because it should be getting all the classes from class DB, I think, but I don't understand the functions very well, like I said. So the selection functions there. I think this is probably this is the class that probably has all the nodes that exist, and it gets from class DB. So I have to understand how is it getting from class DB. Because the thing is, it doesn't show any. It's kind of annoying though. I'm gonna think about what is the easiest way. Because I'm pretty sure that I know what to do. So basically, the way that mental model that I have now, like the scene3 doc has to get classes from somewhere. It's probably coming from class DB. That's how it's going to display everything there. But I think that the classes that displays here, it doesn't have classes related to the GD script, for example. It probably doesn't have all classes that are subscribed to class DB if the class that I have there doesn't show up. Because this build here should have the one that I created there with the register thing. And I think I don't know the specifics, but based on the name there, I'm pretty sure that the file that I think I closed So, but I forgot the name. So there is a file on the main setup. They are gonna look for the modules that are registered using a function there, and that function exists inside of a file that is generated on build time. And obviously, I think the reason why they do it like this is because they want to make it dynamic, so that you can add any module you want inside of the modules folder, and then it's just gonna probably iterate over the modules folder, and for each folder is going to create a function, which is dynamic generator on the build time. That is gonna have the same name of the folder, and that's gonna be the thing that is used there to register the module, I think. So these functions here pretty much are the ones that are going to be dynamic generated, and it finds them there based on the name of the folder, and all the modules do that. So one thing that I can do is just search for. So yeah, that's the thing. There are several different ways to go about this. I have to think about the easiest one. So one thing that I can do is just go to the main setup function, and then put a breakpoint at the time that they. I'm not really sure if I need to put a breakpoint. I can go there and then just see all the modules that are used, and then pick one class of the modules that are used to see if the class is going to show there on the visualization on the scene tree doc. Because I think that it isn't the case. I think that it doesn't show all the classes that. Or I guess I can change the easiest thing is just to change. So I can inherit from node instead. If I inherit from node, it's gonna show, I think. So that's what I'm gonna try to do this first because I think this is the easiest thing to do. So I think that the reason why it's not showing is because this class inherits from object. This is a ref counted. Then object doesn't inherit from anything. It's kind of weird. So let me see. So node cpp. Yeah. Yeah. So this one inherits from object. So I think the ones that show are the nodes. So I'm going to change there to inherit from node and see what happens. Then I think I have to probably need to change here. It's gonna be on scene main node. Scene main node. Let's see if I can compile like this. If this doesn't work, then it might be annoying because I'm gonna have to spend a bunch of my time trying to understand how are they getting the stuff that they display there, and then basically either change, probably not gonna change on the way that they do it, but the way that I'm doing here somehow to figure out, because it must be. Yeah, I don't see any reason why I wouldn't be able to do this, because obviously it has to be getting from the engine. So as long as you understand how the classes are connected to the engine, you should be able to put there. Most times the hardest parts about coding, is just figuring out, because there's usually several different approaches. Yeah, and it's hard to, because like you might take the wrong one in the beginning and then spend a bunch of time and a bunch of stuff that doesn't matter. And then looking back at it, you think about it like, oh, that was kind of dumb. Like I lost a bunch of time, but there's nothing you can do about it because you only know after going. I guess you can derive fundamental principles from this based on experience. That you get fundamental principles and you get reference frames, and then it becomes easier each time. I'll be right back. I'm sure if we said this now, but what is fascinating? Oh, so this is another. So I was gonna stop this on previous time, but I skipped over. Uh, so this, if I remember correctly, so I went over the source codes or the like the labels there that they have on the. So just like anything else, they're gonna have a class that manages everything that happens on the up part there. I forgot how to say this, but on the part that shows up the main options there, that's a class that handles that, and then obviously each one of them are gonna have a bunch of different options. So I just got the labels and I searched for the labels to see because the next thing that I'm gonna do is just study how the save scene functionality is done. And one of the breakpoints, if I remember correctly, is this load scene here. So I think this is what's happening right now. So I think the first time that you open the editor, you're just gonna call this function to load the whatever scene you had. It's probably gonna be based on the editor settings that figures out whatever scene you had or project settings. And this is another thing, I think I forgot to say this about uh, the first time that I was talking about there, is that apparently each node is gonna hold a path, I think, either a scene or something. So it's another thing I have to do, but I'm not really sure. I think it's not necessary to set the path. But I'm not really sure because it's kind of confusing. The mental model that I have now is that everything is gonna be a tree. The main tree is the scene tree, which is the thing that has the entire application, and the root is going to be the window, which is the actual window that you're visualizing. It is created with Windows and the display server. And then actually viewport is going to be, uh, I always forgot which one is which, but from that main scene tree, each scene is going to be a subtree of that tree. That makes sense. So probably what defines, and this is the thing that I have to clarify, what does define a scene? And I think it's probably whether or not the node has this scene path declared. So there's also another function there that I was, since the beginning, I was trying to figure out, which is to change the scenes. I want to understand how this works. But as far as I can think now, right now, I, the way that it probably works is that when you, so the scene is interacting with the node that is the root of the scene, or maybe any node that is a child of that scene. This is the stuff that is kind of confusing. But I think all that it's gonna do is just gonna send a message or emit a signal to the server, or call a function from the server, and then the server is gonna change the scene. Because the main scene tree is inside of the main loop class, and the main loop class is inside of the OS class, if I remember correctly. So the main loop is the one that has the main functions that are gonna run, which are the same for every operating system. It's just the main setup and the main setup, main start, and main iteration. So our path is just gonna be the name of the scene, current scene. Yeah, this is interesting. So, and I remember that there is a data It's not S data, just data. I think either the sync tree or the node. I think it's on the sync tree, and that is a struct inside of the sync tree that keeps track of the data. So this function probably, and this packet, I think it's packet data that they use to store information on the file on the exports. It's probably, I don't think it's related, but it must be like similar functionality. So S data is probably a member variable. It has to be a member variable of this editor node. So it's on the editor node. Yeah, editor node is the main node that displays the editor. So it has the data here. It must be on some other class. It's probably on the editor node. Or editor or data. Maybe not. No, the sync tree should be like it's a separate thing. I wanted to understand the relationship between. So this is a member variable. So no, S data is not a member variable. It's initializing here. Yeah, I'm grouping. But I know that the data is gonna be a member variable of sync tree. So and that's interesting as well. Data. Yeah, remember seeing this. So this is on the node. So it's the node that keeps track of the. So node has a data struct inside the data struct that keep track of the tree. Through this thing here. So when it's calling there, it's calling on the editor nodes and getting the sync tree for the editor node. But it's still confusing because I'm not. I think that this sync tree is just the main sync tree, which has everything, and not the subtree. But I'm not really sure. And this is the data struct that keeps track. And I think here it has the path to the sync. Yeah, sync file path. So I think that this is how it works probably. The thing that it makes it difficult to figure out is that I have to like there's a bunch of other stuff that happens, so I have to figure out on the rendering cycle like how what happens on. I remember there's two different. I think I wrote down here. There's two main functions that two main places that I've seen inside of the main iteration loop that emit events through the nodes, and those are the functions that seem to be connected to the nodes directly because then they're gonna emit events, and then if the node has that function, then it does wherever the function has. And that's probably the functions that show up there on the right of the editor. But I don't remember where I wrote this. Yeah, first place. So this is the functions here. So inside the main iteration, there's going to be a call to the physics process. And inside of this function is going to call another function that traverses the tree. And calls functions are emit signals or something like that. So this is the main one that is not related to the. So the main loop is just the main. Is a main loop class. And the main loop class has the scene tree, which is the whole tree. And inside of the process function is gonna loop or traverse the tree and then call some functions. But it's difficult to think about because this is the problem, is to understand how each node is related to each other and to the scenes. I think I have to swap over the function again and then see if there's some logic that is gonna check to see what scene the node is relative. So the main questions are related to this, like the state management of different scenes, I think. This is, but I think it's probably not worth it to spend time figuring this out now. It's probably better to just figure out how to write to the file first. But I definitely think I have to understand. Yeah. Maybe I do have to understand now, but I'm not really sure. It's gonna come down to how the scenes are saved to the file. Because I do remember that at some point it calls some function to check to see or to update the path of the node, but I'm not really sure if this is required or not. We're gonna continue. So this is probably where it sets the current scene to be that one. Instantiates using this stuff here. Pass data initialized here, which is a package scene reference to resource loader. So it's loading the current scene, probably the one that I had before. The L path is the path to the scene there, to the file. And then uses this. So resource loader and resource savers are probably the main classes used to write and read from the files. I think I wrote something like this here. So it loads that from this thing and then uses this to initialize the S package thing. So this is probably loading the tokens from the file and then from the token. But it's weird that it's not a loop, so I'm not really sure if maybe it loads all the tokens. I'm not really sure what's going on here. So it's probably locking this thread here, but I don't understand the other stuff. Whatever. Yeah, I don't understand. Basically, it's gonna create this from that. So I assume that it's reading the file and just getting the information, but I'm not pretty sure. I don't understand how it does that yet. We'll have to spend a bunch of time, I think. Instead. So this is pretty much the same stuff that nodes, the object has, object class, through subscribe signals. So I guess you can subscribe signals through the scene, but not emit. Yeah, whatever. So I'm mainly interested on seeing what function called this function. And just the general overview, because right after I see if the module works, I'm going to spend time, but I'm going to spend time looking at the save function first. But I think I have to like spend a bunch of time trying to understand everything here. Yeah, so it's like I was saying. So it's loading from the configuration. I think it keeps track of this based on the project metadata thing. This file here, because this is related to the other functions, to the attach script and the create mesh thing. Or attach script, I think. Load editor layouts. Yeah, so it is probably coming from the project metadata file. So every time you change the state of the resources on the editor, it probably update, it probably writes to the project metadata file. I'm not gonna be, but the cells here I remember, and the tree item I remember as well that it shows on the scene tree doc there. I think the cells are which thing shows, which every option that shows there is a cell. So it keeps track on this vector cell. I remember seeing this. I think it was on, yeah, probably both of them because both of them have cells. And the tree item is one of the items, I think. Or maybe the whole thing, I'm not really sure. So it's after an event. So it's on the notification. Notification runs for every node, if I remember correctly. One of those functions there that I showed on the main iteration loop is gonna call this notification for each node. It's a function that I think creates a linked list or gets something like that. It's just iterating over a linked list. It's probably, yeah, I'm not really sure. But yeah, it probably traverses all the tree and calls the notification for each node. And there is different parts of the process for the each notification. So obviously this is gonna happen when the node accesses the tree, probably. And this is for, so this one I think it happens on the thing that I was showing there. I forgot where it is. Oh, here. So on this part here, on the main iteration, where I get calls this process on the OS, the main loop is going to be the main loop class, and that has the sync tree. So this process function, inside of this function, there's going to be another function thing that calls that the emit thing, and then it's going to follow into this branch here. Also, sync tree process group. I think after this is going to show there probably. So I think what you can do, and this is for any node, so that's probably how you do the scripting from C++. You just on this, but I'm pretty sure there are other functions as well. But probably like that's one of the main ones. So you just put the notification, you create a class, and then you declare the notification function, and then put the switch statement. And then for each, depending what kind of thing you want the node to do, you just put whatever function you want inside of that switch, which is probably what I'm gonna do with the graph. But I think that there are probably other functions from the nodes that it calls. So what I'm thinking about doing with the graph is on the notification internal physics process probably, or this. Yeah, the thing is I'm not really sure what is the difference between them. But I think I have to put on one of these physics process, just loop over, just get the nodes. They are children of the current node, and then or get all the nodes that are children, and then get their positions, create the Barn-Set simulation solver, then calculate the new positions, and then set the new positions for each one. The problem is going to be if I can't do that, then I'm going to have to think about how to, because I'm not really sure about the relationship between the nodes. Like if I can only change the position and the physics of the node, the current node, then I think it's going to be a problem, because I'm going to have to spend a bunch of time thinking on how to integrate these things. A sync tree process, and I think so all that happens here, and this is gonna come from the other thing. Yeah, so this comes from, I think it's one level above this. So everything happens on this process here. And so maybe not. I don't know what I've seen GD native, but I don't remember. I do remember seeing some video or something saying that when I search for videos about GD extension, I remember seeing a title or something like that that said that uh, no more GD native, use G extensions or something like that. So I imagine that GD extension is the new version of GD native. but I don't remember. And GD extension is different than the modules. Basically, the main difference is that GD extension you allows you to compile your code separately from the engine, and the modules you have to compile them at the same thing. But I do have to clarify. I have to think about how to. I have to think about questions here. So this is the stuff that I was thinking about doing, that I am still thinking about doing, but I need to clarify. So clarify relationship between the sing tree here and the sing tree on the main loop. So basically the question is, what is the tree on the on data, not tree on the nodes? So I have to understand if this tree here is the entire thing or entire game or whatever, or it is just the subtree that represents the current thing, or the thing that the node is a part of. So I have to think about how what is the best way to go about figuring this out. I'm just gonna press F5. I think that it is not. It's a different flow because it depends on the event, where the event was emitted. But I'm pretty sure on the main iteration is gonna call the process thing, and then it's gonna do the same thing. It's gonna call that notification function. But I think here is different because it was calling that from another place, of where it called that update tree somewhere here on the editor. So I think it's different. I'm just gonna press F5 to go faster. Well, I assume that what this is doing here is gonna be, so this is the label empty that shows up there when you create a mesh that doesn't have a geometry or something like that. So you can select what kind of thing is gonna be, if it's gonna be a sphere or whatever. I think that's it creates the option here. And that's why I put the breakpoint here. So it doesn't create here. I think there's another class, and this class is a part of that class. So this is a class that's gonna have the functionality to decide what happens when you select the thing, because there is also a preview of the visualization. So it shows both on the viewport and on the side there what the mesh looks like. Yeah, so the resource preview, I imagine that is related to the preview that it shows on the right when you select the mesh. It's not the one that is going to show up on the viewport. And I think whatever shows up on the viewport, it comes from a plugin uh, based on the previous times that I step over, but I don't remember. I don't know for sure if it comes or not, but it seems that it is coming from a plugin. The actual stuff that is drawn on the viewport of the editor. So. Better she gets from here. I should make sure that is the same name. Oh, there we go. Nice. So whatever shows up here is just inheriting from node. Or obviously, so in my case, I think I have to inherit from the node 3D because node 3D is going to be the base class. So the way that I imagine is that I do think that this makes a lot more sense. It's probably not the best way. The best way is probably using entity component systems. Yeah, because I've heard that entity component systems is better for applications that the data changes a lot. And it makes more sense because composition, I think it's a gradient of data information. So object-oriented is more solid and less variance. And composition is higher variance and less solid. So you can imagine in a spectrum of solid to gas, like I think composition is not fully gas, but it will be more like liquid, and object-oriented is more solid. So the more the data changes on the application, the more incentivized you are to use composition. And obviously, I think that it is a gradient. It's going to change depending on, because all the applications are going to be a distribution of this funnel of information, so it's going to vary. And the other thing that I was thinking about before as well is that the reason why I don't like the types that much is becoming a lot more clear to me. So types are a description of objects, and that's the reason why it's so hard to get types right, because the boundaries of objects is infinite, because it doesn't exist. So it's a multifractal pattern. And that means that when you're trying to create the code for specifying what the object is almost impossible, because you can't really define something. You can't really describe exactly what something is, because there's always infinite potential in reality. So what something is always relative. And understanding the essence of the thing makes more sense, I think, because like it's gonna be a gradient, obviously, but I think it allows you to understand much more how the thing is gonna interact with the environment, instead of just looking at this description of something and then inferring conclusions based on that. So it's the exact same thing with labels that people. I think that's the perfect analogy. So like people that use types should, like the reason why I don't like when you press F12, for example, on VS Code, and you go to the definition of what the thing is, instead of going to the actual function that creates, for example, on TypeScript, you just go to the class declaration or whatever. That's like when you ask who someone is, and then people say answer you with a label. So, oh, that person is left, or the person is right, or the person is this. So you're placing a label to describe something that is infinitely complex, and it doesn't allow you to understand how the thing is going to interact with the environment. I think that's the biggest problem that I have with types. But to solve this is almost impossible, I think. But I think it can be a lot better than it is. And it's C++, probably the main problem with C++ is that, I think. Because of the nature of object-oriented programming, like C++ is just C with object-oriented programming, because it allows classes. And then the consequence of that is that it becomes a lot more complex, a lot more complicated instead of simple and complex, because it's very hard to get the types right. So it's just the nature of object-oriented programming that it makes things more complicated than they should be, I think. The editor was written, thought the editor was written in GDScript. No, the editor is written in C++, and GDScript is a scripting language that they created to allow you to add scripts on the nodes. So yeah, the thing that shows up there, the ID that shows up, is for GDScript or C#, I think. And the way that it works is that, as far as I understand now, there's a class called GDScript, and that class is pretty much the class that is responsible for creating the script. So the way that it works is just by compiling. So all that is happening on like to create a language, all you have to do is to create rule sets, and a language is basically transitions of states. So you receive a string, and then from that string, based on whatever rule sets you create, you're gonna transform that into a tree Then from the tree, you're gonna derive meaning from the tree by traversing the tree and putting the stuff together. And then the order in which you traverse the tree is gonna determine the meaning you assign to each thing, which is also part of the language. And that's how you're able to. So you're basically just translating a string input into another string input that serves as the interface for the hardware to understand what's going on. And the interface for the hardware is just statically programmed. So it just like it's programmed straight on the hardware. It's called instruction set architecture. So each hardware has instruction set architecture that communicates with the operational system. And then the languages communicate with the OS, which translates the language, as far as I understand now, to the hardware, depending on the instruction set architecture. So the way that they do it, things here, they just use C++, and I think they use a bunch of macros and stuff like that, but mainly that class, GDScript, to translate whatever inputs you put there on the GUI in order to become C++ eventually. And that C++, the resulting C++ is gonna be integrated with the nodes. And I think the reason why it's easier to do this with C++, or to do this with GDScript instead of allowing you to use Python, is because Python and JavaScript are dynamically typed. What that means is that you don't have to specify what type the thing is, which means it becomes harder because during the interpretation or compilation process from Python, there's gonna be some logic there that is gonna determine what the type of the thing is, because you don't specify on the language itself. But because C++ is statically typed, it becomes a lot harder to integrate something that is gonna take the input that you put there and transform that into Python, and then integrate that with the C++ code you have on the engine. So it becomes easier for them to create a simple language that is probably gonna use some macros that are gonna take the input you put there to translate directly into C++, because then it allows them to select what kind of things you can put as inputs. It makes things a lot easier. If I go class, this is basically the class that creates GDScript. So as I understand it, there's a bunch of functions here that are gonna be compilations. So script is probably the base class. So you can have GDScript and C#. And the way that I think that it works, based on high-level stuff that I've seen and the documentation, they have another class called variant on the engine, and that's a C++ class that has basically a bunch of template metaprogramming. Template metaprogramming, all that is just in C++ you can use templates to specify the types of each thing, what each thing is going to be. And the way that you think about this is that it's as if you're creating another class to determine what other classes are going to be, if that makes sense. So for example, a bool here is just a true variable, true or false. So you can look at this bool as being a class, and that's pretty much what a template is. It's just like creating another class and allow you to, because you have the built-in types of the language, which are also predetermined by the compiler, the way that the compiler is going to derive meaning from the words. And those are these built-in keywords here. But then if you want to build on top of that, it becomes very hard, because then obviously, like you have, at some point you have to specify that a variable is going to be a class and not any of the built-in types. And that's where templates come from. So templates is just a way to allow you to specify that something is going to be a class or whatever you want there. And then it's really hard to think about this actually, because you're basically allowing you are allowing the functionality to change the nature of the code as the code runs, pretty much. So this is meta programming, the name. So it's as if like I can create a string here that is like some C++ code, and then at some point I can run or convert this string So if I did this, this is called metaprogramming, where you change the nature of the program and in runtime at runtime. And basically, what the variant class is doing is just using a bunch of built-in functions, I think, from C++ to convert different types into different things. And I think that that class serves as an interface or as a bridge between the script and the C++ code. So probably on the compilation process uh, or the parsing process, they use this variant to get the variables. And I think that's the case because I've seen that on the project settings. The way that they load the project settings is by, as far as I remember, they loop over the file, and then for each variable that the file has, they create a variant equal to that variable, and then store as in the project settings as props. And then later on, they use the same variant to do the other stuff. I remember going over this when you initialize there, when you click attach script, this is the constructor. It's gonna initialize this other probably struct here or class that is member variable of the GDScript with the instance of GDScript. This is similar, but when they initialize the single tools, they do it inside of the class. This, I think, is a similar thing. So yeah, it is linking the GDScript to this GDScript language through this script list. So here it probably has, it's probably gonna store all the languages that are currently available to use. I don't care about this though because I prefer doing on C++. And this is something that I was thinking about as well. I think today or either yesterday, probably yesterday, that like most people, so people usually, I think that's usually the way people do things is they build everything, like for game programming specifically, they build everything on one language, but then they use a scripting language to build the functionality of each thing. And yeah, I'm not really sure if that makes sense, like from a fundamental perspective, or if it is more something that people do it just because everyone else does it. So it's kind of hard to think about it. But one of the main reason for that would be that I think there's two reasons. One is for like if you want to use something that is dynamically typed to put the behavior of things inside of the thing. And the other reason is because of the nature of scripts. So the main difference between Python, and this is something that I learned recently that just clicked on my mind, like not that long ago. But as I was studying something that I forgot, I think probably Python or C++ or whatever, I realized that the way that it works, so every program, as far as I understand, regardless of what programming language it is going to have an entry point. So either it's going to have an entry point by proxy, which means that the language itself is not the one that is creating the entry point, is the language that the compiler was built off that created the entry point. Even if the language is like creates its own compiler after that, like the initial language that created the other language is going to have an entry point. So in the case of Python, C++ created Python, or C created Python actually. The main implementation is Python. So on the Python thing, it has the entry point that comes from C, which is the function main. And main is just a standard that people agreed on that's going to be the entry point for programs. So the main difference is that when you're using Python, you can start the program from any file you want. And that's why it's a scripting language, because Python itself doesn't have an entry point. It does have through C. But then when you run Python, what's going to happen is that Python is going to figure out what file you're running, and then it's going to assume that the entry point is that file. And the way it does that is by the name of because everything in Python is an object. So the name of the file, so yeah, the name of the file, which I think is the dunder method here, is going to be main. That's why you see if name equals main on some files. because whenever you're running from that file, then the name of the file is going to be main. And when you're not running from the file, the name of the file is going to be another thing. And the reason why is because everything in Python is an object, is a C struct, and then inside of the C struct, they're going to have these other methods here. They're going to specify these things. So the main difference of scripting language and other like a normal language, let's say, I think it comes down to that, where scripting languages are more dynamic on their initialization. And it goes back to the gradient that I was talking about between object-oriented programming and composition. It's similar, but it's a different kind of gradient because it's a gradient of flexibility to rigidness, let's say. So if you have only one entry point, the program becomes more rigid because it becomes harder to break the program apart into different pieces. But if you have a scripting language, then any file can be the entry point. It becomes harder to piece that apart. And that's why I think that higher level languages like Python and JavaScript are going to be more like water because they can be composed more, they're more flexible. And the other languages are more objects, they are like ice because they're more static in their nature, I think. And this is probably the reason why on games you use scripting language. There's more of a gradient of information, I think. But the notion of languages itself, I think, is in the way that it is today. I'm not really sure if that makes sense from a fundamental perspective. Because this is another problem that I always have with programming languages since the beginning, that I couldn't find a very good answer to this. Because it seems for the most part that a lot of people, or probably most people, they code something in some language just because it's the way that it has always been, let's say. So people come to the conclusion, or because of their experience, intuitively they get understanding, but they never question that understanding. For example, Python is better for automation and scraping and that kind of stuff. But the question is why? And then the problem that I always have is how, if I want to write something in JavaScript and then I want to embed Python into that, why can't I do that? And then there's some functions that allow you to do that, but then you have to use the OS, I think. And it's very confusing to me. I'm still trying to clarify this out. I'm gonna close this stuff here. I'm gonna continue there with the whatever I was doing. I think I pretty much solved everything. Solved not everything, but the main thing that I wanted to clarify. So now it's very clear to me. So everything that's gonna show there is inherits from node, and you can create whatever node you want. So now I have to think about these other questions here. It's what is the best way to clarify these other questions? Because now I think that is not. I thought that it was going to be a lot harder to figure this out because I would have to understand the GD scripting. But now, if I can do it with this way, so the main thing that I have to study the node class now. The main thing I have to figure out is if it is going to be possible. Because the main block that I'm going to have here is whether or not I can communicate with one node with the other, change the behavior of one node from the other nodes. And what is the relationship between child and parent when it comes to that? Yeah, so this is the stuff that I have to clarify now. Because after I clarify that, then what I can do is just copy the graph class that I had on the other thing. Oh, but that's gonna be, yeah, so now I have another thing to think about because the other one uses boost. So what I can do is just do the other thing that I was doing to, on the headless thing to add the dependency. So I can add the third-party dependency by changing the way that the modules work on the build system. Or I can just learn how they compile the third-party libraries and then just put boost there. I think that makes more sense. Or I can go the other route and not use boost at all and just try to create a graph from my thing. But I think it probably makes more sense to use boost because it was optimized and they probably know better than me. Do you know the engine team has a C Clay John? No, I've seen that they have a special Discord or something. But the thing is, because I don't know the nature of what I'm doing. So like I don't wanna be invested into trying to like change the engine or stuff like that, and I don't wanna waste their time. Know what I mean? So I think it's disrespectful if I don't plan to actually make the team better or help them some way. I think it makes more sense to just use the public Discord to ask whatever questions I want because I don't know exactly what I'm gonna do. Is Clay Jong on GitHub or where can I find this meeting? Yeah, now I have to see the difference on the scene as well. That's another thing I was gonna do. So yeah, but I'm gonna have to see. So now I have to study. So I have to organize my thoughts to see what I'm gonna do. Because to update the scene, you either press Ctrl S to save the scene, which I put the breakpoint here, or you go to the tab there and you do it. So I can either spend time now understanding, because I think it's better to open the one that I don't have the breakpoints and then do this stuff from there, because what's gonna happen is gonna change the file that it has here, which is the current scene being added, and it's gonna write information to this file. So this is the, oh no, this is the GD script. So the wrong file. Is this one I opened with the thing, so now it has this icon. It's kind of, I couldn't figure out how to remove, but whatever. But this is the file that has information. It's based on this information here, I think, that the project settings are gonna parse the file, and they're gonna. So each one of these things, I assume what's gonna happen is that depending on the rule sets that they have there to parse this file with the project settings, they're gonna create prop variables, member variables inside of the project settings, which the prop is gonna be a variant, and the variant is each thing that you have here that represents what the state of the scene. And then they're gonna use that to update the scene tree, I think, probably. So this part is the one that I have to figure out. So I have to figure out first how they are writing the information here, what function they are calling to write, because I don't necessarily need to figure out the parsing. I can just figure out the function that the editor uses and then use that function from them. And I have to figure out what function they use to read the file as well. Yeah, I'm not really yeah, because it's kind of hard to think about what thing to clarify first. This is the main problem I have. But I think probably I should probably figure out how to save to the file. So the thing that I was gonna say, that I was gonna do, I think I'm gonna open another editor, the one that doesn't have the debugger, because I wanna see what happens when I add the custom module class that I did, and when I remove the class, just see how they are storing the information here. And to see the difference between the class that I created and the class that they have here that is built in, to see if there's any difference or not. Because if there is, then probably I'm gonna have to figure other stuff out. Or probably there isn't gonna be. I think it's just gonna be the difference in the name, probably. And this one doesn't have the class because I didn't save yet, but yeah. So after I figure this out and I figure out how to save the thing on the file, then yeah, I think the first thing that I have to figure out is the node. The node functionality is the most important, because I need to understand. I want to develop the graph right away, and also it opens up more questions because I just remember of the boost. What I'm gonna do is just translate the way that I was doing the graph from the other project using Raylib to do the same, pretty much the same thing, but using the class that I add there. It's just gonna be the graph. So I have to learn how to. I think I'm gonna have to integrate boost into the engine. And in order to do this might be very annoying. It might take a lot of time. I have to study how they compile third party, which I remember is kind of hard to see there. but I can look at one example and then see how they do it. Maybe it's not that hard. So first, I have to. So I'm gonna study this. Then first, I figure out how to integrate boosts. Then after I figure out how to integrate boosts, but maybe it's better to, because if the nodes, if I can't change the behavior of the children from the parent node, then it's gonna change the way that I'm gonna have to figure this out. Because then it's gonna be more annoying to think about how to. I was thinking about like whether or not it would be necessary to change the physics, but I think it's not. So the only thing that makes sense to me is that you should be able to change the behavior of the children, or there should be some other way to do this that doesn't involve changing anything on the engine. Because the solving process is just going to be updating the positions or velocities or things like that. And then Godot's physics engine already has that, and it's already integrated with the classes. So I think it makes more sense to not want to change that. You just use the engine that they have with the properties of the nodes that I want, and then change that from a node. And if I can't change from the node, then I think it's going to be that's the part that I'm not really sure how to think about it. But I'll be right back. I'm gonna go to the bath. I have a lot of respect for the people that created this. It's like very impressive. I still don't understand how they Yeah, I have to study more to understand how they thought about the dimensions of the position of everything, and how I'm curious about how they developed the editor in the first place, because obviously they didn't have the editor to develop the editor, so and it's extremely complex, so it's very crazy. It's one of the things that I'm kind of confused about as well, and I have to. It's getting better, I think, with time, which is like using or developing something that's going to be used to develop something else, because the boundary of the application gets very confusing. Like, because when you're developing, like, when I'm thinking about the stuff that I'm going to do here, not only I have to think about how the scene is going to be on the thing, but like how to code the thing that is going to create the scene. That's kind of, and creating the separation is kind of weird of what the functionality that is actually related to the scene and not to the engine. So I'm gonna close everything. I'm pretty. I'm gonna do this stuff of the. I'm gonna study the scene later. I think it's more important to study the. They're both really important though. It might take a long time to study this stuff. So let me see here. So I guess this is one you don't have the. Hmm. So I have to think about, because I think that the logic here is related. It's not necessarily related to the engine. It's going to be related to the management of the scene from the editor classes. So this is the thing. This is the main class that is gonna. This, if I remember correctly, this is going to be related to everything they have there on the top of the engine. So it's all the options that show up there. They are all going to call this function, and it's very similar to the scene3 doc thing. It's like the same pattern. They just use a switch statement. Depending on what kind of thing you selected, you're just gonna send a different uh, variable here when it emits the signal. And then depending on which one it is, it's just gonna select what functionality runs after that. And I'm pretty sure that the close function is here, or the load function to load the scene is here somewhere. So I'm gonna study the node first. So I'm gonna close everything, then step over one more time. So I have this file. So let me see if there's anything get child by name. Maybe it's inside of this data. The question is what is the best way to clarify this? Oh, so it has children here. So I can use this, probably. It's interesting that it's a hash map, though. Yeah, but I guess I can loop over the hash map. So the string name is probably the name of the node, that is the child. And then the node is just going to be the pointer to the node. So yeah, that answers my question. So now I should probably focus on understanding this thing. So probably what I can do is just, like, from the node that I create the customized node. I'm pretty sure that you can add child, obviously that has to be the case. So the functionality that I can do Yeah, I'm gonna do on the headless. So initialize the class. Yeah, I have to check. So I have to see based on the. I think I'm gonna check first because it's easier not to check. So I think easier first, but eventually like check uh, load saved sing file. This is the thing. Like always, there's a bunch of different approaches, so it's kind of confusing to think about it. But I should focus on one thing at a time, so it's easier. But the thing that I'm thinking about now is that, like, obviously each project is gonna have a bunch of different things. So whether or not, because the thing that I'm building there for the headless is gonna be part of the editor, just gonna run the editor. It's kind of like running the editor without using the editor. So I'm gonna have access to all the functions from the editor, but without displaying anything, you're just gonna create everything programmatically. So one thing that I can do is just based on those functions there that I've seen, I can figure out, I can get the current unedited thing or current edit thing, whatever thing there that they load in the beginning on the editor, and then I can from that thing I can load the config or uh, from that thing I can check to see, can read the thing, get the variables from the thing or the data, and then check to see if the thing has the class that I want, which is a graph. Then after I do that, so if it has, then don't do anything. So just continue. If it hasn't, then this is the part that is confusing because in the beginning I'm just gonna do random data. So I'm just gonna transfer this stuff that I'm doing there on the other one. So I'm just gonna create the graph if random nodes. So the way that I'm gonna do it is just by probably using a random number. I'm just gonna get the code that I have on the other one, but then instead of creating the meshes, just initialize using the macro that they use to initialize classes. Initialize the is either gonna be mesh instance 3D or some other one that has the collision, probably the collision one. Then I have to figure out how on that class how to change the state, because the thing is when you select a class, it still allows you to select a mesh. I think it's pretty similar to the way that 3ds works probably, where the mesh has the material and has the geometry. So the geometry is how the buffers are going to understand the data. So the structure of the buffers determines the geometry because it's related to the position of the points that is used. Another thing that I learned that I think is very interesting and is related to the nature of the universe is that based on the guy that I'm watching a bunch of videos of, which I think it makes a lot of sense what he's saying, and it's something that I was thinking about for a long time, and I think he speaks about things that he has more clarity on the details and some other stuff that I didn't think about because I was going to study this, but I didn't study. I think it's which he speaks about the nature of the universe, which is electromagnetic, and I agree with him. And I was thinking about it, but from a different angle. But I think I think we're probably saying the same thing with different words. Now, the thing that I don't like about this guy is that he's very arrogant. So, but what he's saying seems to be very true. So, and this is related to the visualization because it reminded me of the edge function. So basically, what he says, like, I'm probably butchering what he says because he goes a lot more into detail, and there's like some nuances that I'm not really sure. But I pretty much agree. So the way that I was thinking about the universe is that everything is a multifractal, because the boundary between things are an illusion, and they are an illusion because they are a projection of the frequency of awareness that you have on the current moment in time. And time doesn't exist because, and this is a paradoxical thing, but that's pretty much how it works. So every boundary is just an illusion because it's temporary, and the nature of time is just a measurement of the differences in boundaries between things, and that's a multifractal pattern. So space is not fundamental, and consciousness is fundamental. That's how I was thinking. So the universe is mental. But I think more from my perspective that it is a paradox. It's not mental or physical, it's both at the same time. And what creates the duality is the awareness of the presence, which is a hologram. So the way that he describes this is everything is electromagnetic, and you have the dielectric, which is the like, is the point of less pressure between two different poles, but that point doesn't exist in space. You just from the perspective of space, it is located in the middle or the center of the electromagnetic field, but it isn't actually on that center because it's relative. So that point doesn't exist on space. Is a counter space, and counter space doesn't have measurements, and space is a shadow of counter space. So counter space is just infinite potential, which is the way that I was thinking about things as well. And that creates gravity because the nature of things is the tendency for incoherence to become coherent, and that's the attraction of gravity. So, and that's the nature of the electromagnetic field. So that's the moment of inertia. And this part I'm not 100% sure because I don't have the details very clear on my mind yet. And also I don't know very well what is the relationship between this and the complex plane, but I'm pretty sure that is a relationship. There's also this fractal woman that she talks about this, which is is exactly the stuff that I was thinking about before as well. The first time that I saw the Mandelbrot, not the first time that I saw the Mandelbrot, but I knew there's something there. And the first time that I saw the Julia set, which is a variation of the Mandelbrot. I don't remember the relationship between them, but it's pretty much the Mandelbrot with some differences, or on the line of the boundary. So basically the way that fractal works is that you have the part that is inside of the fractal that doesn't converge or diverge to infinity, and I have the part that is outside that diverges to infinity. And the boundary between them is the multifractal on the complex plane. And basically what I think she says is that the Mandelbrot represents the curvature of space-time, but I'm not really sure if that's what she means. And I think that makes a lot of sense. So the model that I have right now is that the relationship between counter space and space is a multifractal boundary, which is a singularity, and that boundary can be observed through the complex plane. So space-time is a projection of the space-time is a projection of the complex plane, but it's not like the complex plane is the ether, which is the point of the infinity, of infinite potential, which seems to be in the middle, but it's not really in the middle because it doesn't have properties or attributes or whatever. It just seems to be in the middle, but it isn't. So obviously the complex plane doesn't measure that because by definition that would be not measurable. But the complex plane is like the projection of the space-time, but I'm not really sure if that makes sense or not. And the boundary between the two is what creates the multifractal, which is the nature of the distinction between things that doesn't really exist. So what that has to do with the visualization is that basically the way that the electromagnetic field works is through a torus. A torus is just like a donut shape, and you have this principle of incommensurability, which is the stuff that he talks about. So you have the torus, which is that shape, and then you have the other shape that is the negative image of the torus, pretty much, which I forgot the name. And those two together form the electromagnetic field. And in order for the donut shape to exist, you have there's two different cycles. One, and this is another very interesting thing that I figured out, is exactly this image here, which I thought is very interesting. But basically, you have two different cycles pretty much. One goes counterclockwise and the other goes clockwise, and that forms the electromagnetic field. And the interesting part is that whenever you're going to render anything, you have something called an edge function. And the edge function determines what vertices show up first and what vertices show up in the back. And this is used for backface culling. So it's pretty much the same thing that is happening. So the nature of the order of the function the order of the edge function that you select, if it's either going to render points counterclockwise or clockwise, is going to determine the visualization you have, which is the same dynamic of this electromagnetic field. It works pretty much in the same way, and then you can view the camera as the projection. So the other stuff that is very interesting is about 3 blue 1 brown that I've seen that is like pretty much the same thing as this image here. That really I thought it was very interesting. So I'm pretty sure there's something there, but I'm still not really sure. I'm trying to figure out, but just basically on these videos here that are extremely good, by the way. From is the Ben Neater, the guy that I talked about all the time, that has the best playlist on YouTube to understand how computer works. So these videos here, one of these videos, there is I think it's pretty much it's either this one or this one. These videos are pretty much creating this stenographic projection, the visualization of the four-dimensional field, which is one real number and um, three complex numbers, and it has to be done through a stenographic projection, which is just basically the variance of the colors on these things here. It would represent a different dimension that you can see because you're in 3D, and it's obviously 4D on this visualization here. But the thing that I thought that is really interesting is gonna happen, I think, is on this visualization. And that's why I think there's something there. But it's kind of hard to grasp exactly what it means. But I'm pretty sure there's something there. The way that I was thinking about it before, that I'm not so sure about it now, is that the mental model that I had before is that the space-time is a projection of the complex plane, and they're both symmetries. So because perception is symmetry, so when you have an external observer and internal observer, that's the nature of reality, and it's an asymmetrical symmetry because it's a paradox. So because reality has infinite potential, it can't be a symmetry, because a symmetry would imply that you have a limit. But because the nature of perception, you need to have internal, external. So everything is a duality, which is the principle of incommensurability that he talks about. And this creates the nature of time and space, which I used to believe, and I'm not 100% sure now, but based on what he says that is the electromagnetic field. And I used to think that is, which I still do to a certain extent, because I have several different questions. I have like billions of questions. But I think that's pretty much the same thing, those things. So like the nature of awareness is intrinsically connected with the electromagnetic field. And both of these things are a paradox, because you can't really understand them through knowledge, because the ether, by definition, is irreducible through space. And there is a point at which is still reducible, which is the event horizon of the electromagnetic field, or the dielectric, which is the part of the electromagnetic field that creates the gravity, because it has infinite potential. It looks like it is in the middle, but it's actually on counter space, which doesn't exist on space because space is a projection. So it's like from space, it looks in the middle, but it's actually not anywhere. So it's everywhere and nowhere at the same time. And the event horizon, I think that the event horizon of that is probably the complex plane. But I'm not really sure if it's the event horizon or if the complex plane is the reflection. So it doesn't make sense for the complex plane to be the counter space. I think they're just true. So complex plane is probably North Pole, and space-time is South Pole, probably, or the other way around. And the dynamic between the two creates a multifractal, which is the event horizon of the black hole, which is the dielectric, because everything is an electromagnetic field. So time is the measurement of the multifractal boundaries on the of the space and complex plane. But this thing here blew my mind, and this is the thing that I'm trying to figure out, because I think there's something here, which is related to quaternions, obviously, because these videos are about quaternions, which are used to rotate an object on the complex plane. So I think that the reason why on the complex plane it doesn't have gimbal locks is probably because of this, the relationship between the complex plane and space, because they're mirror reflections of each other through the ether, which is infinite potential, that doesn't exist on space because space is a projection. But the thing that is kind of hard to think about is What exactly is the reason why complex plane doesn't have the gimbal lock? So obviously you're doing the multiplication 2 times because you're transferring the information from space to the complex plane and then back again from complex plane to space. And I think that this jump is the thing that is kind of confusing because I'm not really sure if it would make sense that you're jumping through the ether because I think it doesn't make sense, but I'm not really sure about it. So this is basically the question, but you can see here that this pattern here is exactly the one that shows here. It's basically the same thing. It is an electromagnetic field, which makes me think that the scenographic projection, the scenographic visualization of the complex plane of this quaternion is basically the same thing that is happening on the electromagnetic field. The electromagnetic field is just a lower dimensional visualization of what is actually happening on a higher dimensional plane that comes from the ether. The only problem on this one is that I don't think you can change the name here, the value, the intensity of because it only measures for one, I think. And these ones is just the rotation of the sphere. And this is another thing is that the other thing that he talks about is that, which I also agree very much, is that there are no straight lines on reality. Because, and this brings me to another thing that I think a lot of people don't understand about the paradox, because the Hubert hotel thing, where when people say that you have a hotel, then you have a bunch of people that are going to be on the hotel, and basically the point that they make is that you have rooms increasing for infinity here, and then you have another thing increasing for infinity down, which means that the diagonal is going to be greater. So one infinity is greater than the other, which is a paradox, but I don't think that makes sense. And I think the reason why it doesn't make sense is because lines are not straight, they're curved. So when you go far enough, what's going to happen is that the line is going to bend on itself and it's going to pass through the infinite point of the ether. And at that point, the distance becomes the same for all the lines, regardless of what path you take, because they're always coming back to the source. Which means that there isn't one infinity is not bigger than the other. Infinity is always infinity. What's changing is our perception over infinity, because our perception is mathematics. Like the way you describe your perception is mathematics, which is just a language, and mathematics can grasp the ether because the ether is not reducible. So I think it makes a lot of sense. And I think it is exactly the same thing that is happening here on the stenographic projection, because it's showing a lower dimension here is representing in 3D space something that is on 4D. What happens on the stenographic projection is that it looks like it's becoming a plane. So things are converging or diverging towards infinity. But that's not exactly what is happening. It's just that you're lowering the resolution of information you're getting. So Norman, like Norman Weidelberg projective geometry. I feel like I'm very close to figuring this out. Like, but there's something that I don't understand still. I'll check it out for sure. Basically, it is a hologram because that's what a fractal is. So it's a like self-similarity. And he speaks about water as well, which changed my mind a little bit about. But this is this stuff that I'm not 100% sure that I agree with him or not, because I don't know very well. Like he basically says that it's only possible to have consciousness if you have water, because the water is the only molecule that has a polarity properties, which is the isosceles triangle, which is the geometry that is necessary to create this incommensurability property, which is the nature of the electromagnetic field, I think. So he says basically that water molecules store everything by resonance, which makes a lot of sense to me. I never thought that the brain stores information. The way that I always thinking about it is that like the eyes and everything you interact with is a portal to your body, and your brain processes that. So when you are learning something, you're downloading data into your body. So I always thought like that, that is stored into our body. But I think I'm not 100% sure, and I don't think it is on your body, and that he talks about that as well, because it's more about resonance, and resonance and harmony is not about the location in space, because in ultimate reality, space is a byproduct of ultimate reality and not the other way around. That's why I think it doesn't make any sense to think about the Big Bang in linear time, because that's not how reality really works. I think the only reason why people think like this is because they don't want to confront the like scary stuff that comes out of assuming that reality is infinite, because then it brings a bunch of uncomfortable feelings. But I think that that version makes a lot more sense to me than the version from Einstein and quantum mechanics. Because like, it only makes sense, like it doesn't matter which way you think about it, like it has to be infinite at the base layer. Because if it wasn't infinite at base layer, it would have ended already. So like it doesn't make sense. So the bottom layer of reality has to be infinity. And infinity means infinite potential, which means that it doesn't have a location. Because if it had a location, it would be confined. So it makes a lot of sense that space is the holographic projection of the ether. No, I don't know. But the main question I have now is what is the relationship between counter space and space and the complex plane? So what is exactly the complex plane? Because I think that if you think about it, like complex plane is a measurement of the lack of something. But he already says that space is the lack of space is the shadow of the ether, so it doesn't have properties, and you can't. It's not a thing. It's the lack of a thing. That's what he says, which I think it makes a lot of sense. But then what would be the complex plane? Because a complex plane is just like you're taking a negative number and you're squaring that number. So it's like you're going inside of something. That's the thing. But like if space is a shadow, then it can't mean that you're going inside of space, because space doesn't exist. So it's just a shadow. So you would mean that you're going inside the ether, which that could make sense, because you can think about it as the complex plane being the imagination and abstraction. It's like the place of ideas, because everything is a dream. So the singularity point that connects the two is the dualistic notion, the polarity of reality. So reality is the singularity point, which is the paradox that creates the projection, which is going to be the relative polarity being between imagination and abstraction, and space and time. And if that's the case, then the complex plane is just a mirror projection of reality that happens on imagination. And what you're doing when you're doing the quaternion rotation is you are taking something from space and moving to the imagination plane, and then doing the rotation there and transferring it back. But the question is, why doesn't it create a gimbal lock if it is on the complex plane? But it does create when you're on space and time. And I think it has to do with the resolution of dimensions, probably. It's something related to that. Because here you're also using one extra dimension to represent the rotation. And on space you don't. Unknown reality. It's very hard to think about these things, because you have to be careful as well, because there is a problem that's because it is essentially what religion and all the other stuff does. They take something that sounds very true, and then they hijack that and they change it a little bit, and the reason why is because they want to control your mind. So it's a slippery slope, and that's why you have to be very careful. So like spirituality says, for example, that you shouldn't sing, because sinning is bad for you, and then the church comes and says, uh, you shouldn't sin, therefore you should listen to me for everything because I know when you're sinning and when you're not. So pay me money, and then you can get into heaven. So like essentially, it becomes something that is true, but then it's hijacked by the devil to control you, and that's always happens because it's just part of the nature of reality, and everything is a fractal. So it becomes fractalized. So when it comes to these things, it's very hard to think about because you essentially hit the limit of science when when you get into the ether, and that's kind of the problem that I have, and I don't understand what his perspective is when it comes to that because I don't know if those things are the same because in the way that I was thinking about it is the gravity is God and is awareness pretty much, which is I think is different than saying that the gravity is the dielectric, is the relationship between the dielectric and the pulse. But then like that's kind of the question is what determines how what determines the gradient of electromagnetic attraction that the two poles are gonna have. Essentially the nature of the matter and the geometry. Because what does it say? If the ether is not anywhere, then what determines when two things are gonna have attraction to each other and create the electromagnetic field? And then you can say that that's the lowest mediation pressure point between the two, which doesn't happen on space, happens on counter space, and that creates the attraction. But then, like, what determines what the point is going to be, uh, which creates the differences in attractions. And I think that's probably related to the mind and consciousness. And that's why it's a paradox and it's probably impossible to understand very well. And the problem with that, it goes back to the church. People are going to use this stuff to try to control you because, and this is the whole point of having science because it makes things more reliable because you can run experiments and then you can derive conclusions from that. But that's where this stuff breaks down on quantum mechanics. But I think that quantum mechanics doesn't make a lot of sense. I think the stuff that the guy is saying makes a lot more sense. I still don't. I want to understand the relationship there. And I think that the Fractal Woman has a video about this as well. Probably gonna watch that again. Janet is the one that I'm searching here. I'm not gonna read books because it's gonna take too much time, but I'm gonna watch videos. Do you have any video in particular that you think is gonna be better? What's the title of the video? Unknown reality. Basically, the main question that I have now is why does Euler create the gimbal lock and the quaternions don't create gimbal lock? It has to do with the order of rotations, obviously, but because that's what gimbal lock is. But like, what does that say about the complex plane that is different than space? Or is it just because it's using another dimension? But I don't think that's the case. Maybe if you used another dimension on space, you could avoid gimbal lock. So if you keep track of time, for example. So it could be just that is using, but I'm not really sure if that's the case or not. I think it's probably not. I remember like watching videos about that, but oh, this is the audiobook. Do you know if this is the full one? Like which one of these? Because here it says part one, and here it says part two, but it's from another person. Oh, it's from the same one. So I guess it's just it's two parts here. Yeah, I'm gonna uh, listen to this through here. I'm gonna listen to the beginning and see if it resonates with me or not. Because it's very long. But which one of these, if you're still there, which one of these lectures here you think is better? No, probably this one. It's interesting. And this looks interesting as well, just because of the shape there of the toros. It's not the toros, it's the counter thing of the toros, but I forgot the name of that. But I have a bunch of like billions of questions. I'm gonna focus more on the quaternion stuff to see if I can find anything. I have to rewatch. I remember there are video on the complex plane as well. That is very hard to. I think complex plane explain or imaginary numbers explained simply or something like that. But there are some videos that I remember that I seen that I have to review because they explain or to clarify more. But I don't think there isn't any video that explains the quaternion. I don't know why is it different. It's basically this one here, and there's a playlist there. So these videos are very good to explain, but it's not necessarily. Maybe watch through Below and Brown again. These videos here are very good, for sure. All of them from the website there that they have on this video here, the description here. But I do think that this is the same as representing the electromagnetic field. Yeah, I like it too. But the thing that I still struggle with this is understanding the visualization very well, because there's a bunch of different colors and it's very confusing to think about. Obviously, just by the nature of the thing, it's like 4 dimensions representing 3. So, yeah. Yeah. I'm gonna stop streaming here because the timer went out there. I'm gonna continue to do this stuff here for some time off stream, maybe half an hour. Basically, or maybe let me put half an hour here again. So let me just. So I'm just gonna spend some time studying the node. So basically now I know that I can get the children to through the. I'm gonna write on here. I have choose. I'm gonna look into that function. Yeah. Thanks for the suggestions, man. If you have anything that you think is interesting, either from those people or from someone else, to understand quaternions, I've never seen and never found anything that explains why quaternions don't have gimbal lock, but Euler has. I think probably no one solved yet, but I'm not really sure. But there might be videos that help clarify. I think I have to watch the True Blue and Brown again to understand the relationship, or to understand the visualization more, how the standard graphical projection creates those lines there, the curved lines. But basically, when you change the real angle, it's gonna rotate the thing, and the rotation is shown by this, like the plane, because I think that the ball there is just stenographically projected. I don't know. Oh, this is changing the F. Yeah, just remember. Yeah, so when you change the angle changes the magnitude of the F there. So when you change the angle, you're changing the value on the real plane. So you're changing the real value. And I think the sphere is the stenographical projection of that. So when you reach 90 here, I think, probably 90, it creates this stuff. And this goes through infinity, I think. So it's 90 here and 0 on the other one. So it's probably the other way around as well. So I put 90 here and 0 here. Interesting. Hmm. I don't remember this. I think the sum of the square roots of all of them to the power of 2, it has to be equal to 1 because it's just a unit thing. But I don't remember if changing this stuff changes. No, it just changes the axis of rotation, I think. Yeah. But this is still the same thing there. So I think this is the thing, is because on the 0, and the guy that I showed there, he talks about this as well, that you have the prime numbers and there's relationship between the prime. that 0 is infinity or something like that, and 1. I don't remember exactly what he assigns to each thing, but he says the fourth number is time, and time is not a prime number, and that's how you know it's not real, because time is just a measurement. Obviously, that makes a lot of sense, because when you have time, it's just measuring the differences in space. But I still don't know very well, like the details of that. And what it means for inertia and the dielectric field. But I think that there is a relationship here, because the angle is 0 here on the real part. And when the angle is 0 in either one of the sides, it creates the multiplication creates this graph here, which remembers the electromagnetic field based on the lines here. So it could mean that the electromagnetic field is a projection. The perception we have of the electromagnetic field on space is just a projection of what's happening in the complex plane. But those things are essentially the same. They are not the same, they are inverted. So they're like opposites. It's an asymmetrical symmetry. The same way that you have women and men. Women are different than men, but it's a symmetry in an asymmetrical way. So it's pretty much the same relationship between. So like the complex plane is the symmetry of space, but it's not the same. It's different because it's asymmetrical. So asymmetrical symmetry, the point between the two is the singularity, which is the ether, which has infinite potential, just creates a hologram. But it's still not clear on how does that allow for no gimbal lock when you multiply. It might be not because of the complex plane, but because of the transfer of information from the real to the complex. This might be the case here. Yeah, not sure. I just spent a bunch more time trying to figure this out. So I have to see. Let me think about. So I can search for a place where. Actually, they do have. So it makes more sense to see how they're gonna add the editor node to the sync tree. Obviously, they're gonna use either one of these functions. I have to understand what is the. Oh, there's another add child here. So obviously, it's gonna be the event there. I think the differences. This notifies the tree or something. So probably this one is the one that I'm gonna use. Yeah, but it's becoming a lot more clear on my mind what I have to do. So just next step is gonna be to change the summator class to be a graph class. Then I call this function. I think right after I do that, the next thing I have to do is to understand the scene. It's not that hard to understand the functions of the node here. I'm gonna spend some time like figuring this out, I think. Like clarifying exactly how this works. Also, this calls the other one. But basically, it's gonna be creating the graph node on the headless thing, then adding a bunch of children to the graph nodes. There's gonna be the spheres and the torus. So the other thing that I have to figure out is how to change the state. Oh, integrating the boost library is gonna be annoying. How to change properties, but that's gonna be easy. A sphere and tube, sphere, tube, and cylinder, which are the geometries that I was using to create the edges of the graph and the sphere. So I'm gonna obviously initialize the class, then change these properties to in the same way that you would change on the GUI there to select each thing. Then after I do that, I can. This part's gonna be kind of annoying as well. It has to be so yeah. The way that it's gonna work is it has to be a function. Like the solver has to be a function on the node that I create. It's gonna just run barn sut based on the children that the node has, and it's gonna run on the physics process part. So in the initial positions, I can initialize each mesh with their initial positions based on random numbers at first, and just add those nodes. So one thing that I have to figure out is does I assume that it probably does change how because I have to see. Obviously, I'm gonna create the main thing first from the thing, from the code. So I have to. I think it's gonna be stored somehow. So, but once I figure out, and maybe it's better to leave this stuff after I figure the other stuff. So probably here. Because it's better to know how to write to the file. As I learned how to write to the file, I'm gonna learn this probably. Because the idea is to create the nodes programmatically first with the properties, which is gonna be random positions for the sphere, and then connect the edges based on the positions of the spheres, and place the cylinder based on the. For that, all this stuff, I'm gonna have to look into the other project that I have, just translate the functions to C++. It's gonna be kind of annoying as well. But then after I do that, then I think that I don't need to do anything. I just write the class to the file because the class is gonna have the function that calls the solver. So I think if you want to only call the solver based on a control node, that's gonna be kind of tricky. So I have to think about how I'm gonna do that. This is probably the most difficult part, is clarifying, because the relationship is different between the way that I was doing before and the way that I'm gonna have to do now, because the transferring of data. So like the way that I was doing before is I have the GUI elements, and then from the GUI elements, I send the data from that to update the physics. But here, I'm not really sure how to do that, because if I put the functionality to create the solver on the node, then it's gonna run the functionality regardless. So I have to think about, but I guess I can connect the nodes. Yeah, it has to, it's gonna have to be through the hierarchy somehow. And this is kind of the annoying part. But I guess, so I can probably search, but this is gonna be like after I solve all the other stuff, so I don't know why it's doing this. But it's basically it's similar to context in React. So yeah, I think it's exactly this problem. Yeah, it's exactly the problem because I have to transfer information from one node that is in one part of the tree to the other node. So it's going to be the same pattern. So I need to see if there's something related to something similar to context on Godot to pass to translate the information from nodes that are on different branches of the trees to each other. And if there isn't something like that, I'm gonna have to create it. Probably not that hard. Just create a global object. But I think it's gonna be the same principle. So I'm gonna stop here and maybe do some stuff now after the stream, but probably not. And I'm gonna continue to do this stuff tomorrow, but I'm not really sure if I'm gonna stream tomorrow, or maybe. So, but after Next stream, I'm definitely gonna continue to follow the steps here and do what I said now. So see you then.